Today I will talk about research on women and science, lessons from the baby boom. This is joint work with Scott King, who is a first-year PhD student at Wharton. Women are severely underrepresented in science, both at the college level and particularly at the faculty level. Part of this might be driven by an unequal burden of parenting. In 2018, for example, the American Time Use Survey found that mothers spend about 50% more time on kids and chores compared with fathers. Mothers even do more housework and childcare if they earn more or when their husbands are unemployed. We will look at the effects of parenting during the baby boom in a period of very many births between 1946 and 64. We will first look at whether there is gender inequality in science. Then we'll see whether some of that could be due, or how much of it could be due to a disparate impact of parenting. We will use patents to investigate differences in productivity of scientists across the life cycle. And we'll do an event study of marriage to see how patenting changes after scientists get married, depending on whether they are a father or a mother. And then we'll see how that leads to differences in promotions, particularly do people get tenure-track jobs and then do they get promoted to tenure? And finally, we'll look at selection, and I will talk a little bit about this potential social costs. And specifically, you will be using data on entry into science. Let me tell you about the data that we're using. We're using something that's called the American Men of Science. Now, despite this name, the American Men of Science actually included lots of women. So I'll show you one, and at that example, I will explain to you what is in the data and how we use the data. This is Gertrude Bell Elion. We use her name to assign her gender. Gertrude is a female name, and we use that with the Social Security Administration data. And we'll also use her full name, including the middle name, to assign her with her patents. Then we'll have her age. We know precisely when she's born and we know where she's born, and we can use that to assign her to a cohort. And this is really nice. It's a very nice feature of the data. We not only know her discipline, but we also know her research field. So we know the topics that she's looking at, and we use these data to assign every scientist to a research field. So we can look at selection into science, and we can also look at differences in the propensity to patent across fields. The other nice feature is that we know when these people got their degrees and how they progressed to the through their careers, so we can look at their promotions, how long it took them to get somewhere, and also what was their probability of getting to the next stage. So our next example here is Helen Wallace-Tulin. She got her Bachelor of Science in 1929 at the age of 17. She got married in 1930 and she had 3 kids. Then she got her PhD at age 34, 17 years after her undergrad, and she became an assistant professor 7 years after the PhD. Because she tells us that she was an assistant professor, we assign her to be an academic scientist. And when we're looking at promotions, we're only looking at people who actually decided at some point to take an academic job. Another example here is Juliana Tesoro. So I want to show you Tesoro because we know that when she got married, and so we can put the marriage date here, and then we match Tesoro with her patents. And what you see here is that Tesoro, after she got her PhD, she got married basically immediately. Then she was very unproductive for about 10, 12 years, and then became very productive afterwards. And those are the patterns that we're going to look at in the data more broadly and systematically. How do we assign scientists to names? So we use the US Social Security Administration data between 1880 and 2011 to assign something to be a female name. And then we use patterns to measure productivity. So the nice thing about patterns is that it's very, very systematically available. We can also pinpoint the time of the application for the patent, which we use as a proxy for the invention. And then we have a very nice, very clean, nice matching process. And another nice thing we can do here is that in some fields, people patent more than in others. I already told you that we can match scientists to fields, so we can control for differences in the propensity to patent across fields. So now using these data, let me show you some results on productivity. So the first thing that you notice is that women patent a lot less compared with men. That is consistent with women maybe not being put on a patent. But I think our focus here is really on parents and what happens differentially to mothers and fathers. So that's the next thing that we'll look at is whether mothers patent less compared with fathers. And so here we see that if you're a woman, you patent 5.8 less. If you're a mother, you patent minus 0.9 point less. Putting that together and dividing it by the pre-baby boom mean means that mothers, on average, patent 77% less compared with fathers. And then interestingly, if you do the same thing, comparing mothers with other women, so we're adding up the parent variable and the female parent variable here, comparing that with the pre-baby boom mean, what we see here is that mothers actually patent 9% more than other women. And that might be due to selection, which is what we are looking at later. So this is already one indicator that maybe only very, very exceptional women survive when they have kids in science. Another interesting thing to look at here is that for women, it seems like the first kid is really the big productivity killer. Whereas for men, they become more productive with every kid. And we can only speculate, like, why are men becoming more productive? But say one reason might be that there's specialization. Say the man goes out and becomes a scientist, focuses on their career. So then the mother stays at home, and with each kid, there's more specialization, there's more demand. So men actually have to work more. Then a really, really nice thing that we can do with these data is that we can look at how productivity evolves over as people age. So now we're comparing first mothers with fathers, and what you see is that fathers become more productive until their late 30s, but then slowly decline after age 40 and become less productive. Mothers have a very different time pattern of productivity. They're much less productive in their 30s and in their 20s and early 30s, and they become more productive after age 35 and actually peak much later compared with fathers. You can also compare mothers with other women. So here also you see that mothers and other women actually look fairly similar until about their late 30s. Then mothers patent more late in life. So that is also stands out in this comparison as well as in the other comparison compared with fathers. And then it's interesting that if you compare female and male scientists without children, even though the levels are different, the changes over time, the changes across the life cycle actually look very different. So they have very similar time patterns over the life cycle in productivity. So now we're going to look at that more systematically in regressions where the outcome variable is the patents by scientist I of demographic group D at age A. So we'll estimate separately regressions for mothers, fathers, women without kids, and men without kids. And we're controlling for year fixed effects, for birth year fixed effects, and for field fixed effects. And we'll compare everyone with themselves. So I'll compare a mother with other mothers at age 20, with themselves and other mothers at age 20. So again, what you see here is that Fathers become more productive until their late 30s, then plateau and become less productive after age 40. Fathers are always slightly more productive than other men. Mothers are less productive between the ages of starting after the ages of 25, when actually I'll show you the scientists that tend to have kids. And then mothers become slightly more productive in their late 30s. So now we'll look at an event study of marriage. And so why are we doing this? Well, we ideally want to understand the impact of parenting on gender inequality in science. Ideally, we would just assign kids randomly to scientists. So we would randomly assign fertility. We obviously can't do that. So what we do instead is we'll estimate an event study of marriage. And we take advantage of the fact that marriage is a very discrete event, so that any changes in your productivity of marriage, say you get married and you have your first kid, and it generates a very sharp change in productivity, whereas all the other things that influence your productivity across the life cycle are much smoother. So this approach allows us to identify the effects of getting married by that comparison, by the difference between the drastic change in productivity as a result of marriage and those more smooth changes in productivity across the life cycles. And the other thing that it allows us to do, it allows us to trace out a long-run trajectory of productivity after marriage, which is what we're really interested in. So our event study here has as the outcome variable patterns by scientist I in demographic group D and year Y after marriage. We'll have, again, year fixed effects, we'll have birth year fixed effects, and we have field fixed effects. And the comparison group, the excluded group, is the year just before the marriage. So what you see here is that, again, fathers and other men become more productive after their marriage, and women become less productive, both women with and without kids. But what is really interesting here is that the mothers actually recover 15 years after marriage. So 15 years after marriage, these two trends diverge, and the mothers become much more productive than the other women. So now let me show you some data on differences in the rate and speed of promotions. So one thing that people have looked at a lot is how investments in education vary for women and men. And so a woman might be less likely to invest in a PhD because if she has kids, she's going to spend less time in the labor market. So therefore the payoffs from investing in PhDs are lower. It may also be that if I expect not to get tenure anyway, I may just drop out and not get my PhD. Both of those factors would lead female scientists to be less likely to have a PhD. It could also be, if there is labor market discrimination, then I may either decide I have to signal that I am very smart and I have to get a PhD, or I actually have to be, another way to think about this, I have to be more qualified to get the same job. And then female scientists are more likely to have a PhD. Now, so this paper is historical, so let me also tell you that at that time, there were still lots of formal and informal barriers for women to get a PhD. And some of that may actually persist to today. So for example, Joan Steitz, who's now known as the queen of RNA, was turned down by a professor at Harvard in the 1960s, arguing that, well, you're a woman and you'll get married and you'll have kids. So what good will a PhD have done? She got her PhD anyway with somebody else, which was a good thing. So what in our data, what we see is that women are actually more likely to have a PhD, and that's consistent with women actually having to be better, or women having to be more qualified to get the same job. 84% of female academic scientists in our data had a PhD, compared with 78% of male academic scientists. Now, how does this translate? How does it go on in the next step? There are lots of examples in our data, and also when you read generally, of women having to go off the tenure track because, say, they move with a spouse. So this is one example, Esther Lederberg. And so that would mean that women actually are less likely to get these assistant professor jobs, or they may actually be they may take longer to get to them. Again, this is what we see. And we see it differentially for women. 30% of mothers who are academic scientists become assistant professors, compared with 45% of fathers and other women. Mothers also take a lot longer to get that first job. So mothers on average take 4.4 years to get their first tenure track job, compared with 1.3 for fathers and 2.8 for other women. Now let's look at tenure. Mothers who are academic scientists were 21% less likely to get tenure than fathers, and 19% less likely compared with other women. So what it looks like is that the likelihood of the tenure penalty, so the fact that women drop out at the tenure stage, seems to be predominantly driven by women who were mothers. You see this very nicely in the timing data. So in this graph, we plot the years that it takes somebody to get from PhD to assistant professor. And what you see here is that mothers tend to drop off after 5 years, and they just never recover. So the gap here really happens, and I think this is because mothers tend to be productive later in life. When their kids are older, it's just too late for getting tenure. Let's look a little bit at selection in the few remaining minutes I have. Female scientists responded to this. So they were less than half as likely to marry compared with men. 40% of female scientists were married compared with 80% of men. Female scientists were also, they married much later than the population. This is compared with the population. And now I'm going to show you the same comparison relative to college-educated women. So you see our scientists here, and our scientists married a lot later than college-educated women. In fact, they actually sometimes they married later than the men. Very few of them had children. 22% of the female scientists had children, compared with 74% of men. And when you're looking at productivity, there's really no evidence that mothers were less productive than other women. Now we can look at selection into research fields. So one thing that Claudia Goldin, for example, has looked at a lot is that whether women are more likely to select into family-friendly occupations. And so we can look at that within science. And within science, historians of science have said, like, well, one of the reasons why science has so few women is because they were just not interested in these fields. They were not interested in physics, for example. So in physics courses, boys outnumbered girls 3-1, Kevlas, for example, says. In our data, that's not true. So actually, he did not have, I think, systematic data. So mothers actually are more likely, or women are more likely to go into physics and mathematical analysis compared with men. So this is this figure here. Let me show you some data on survival. Do they survive in science? To do this, we matched faculty directories with the men of science in 1956. What we see here, women were less likely to survive. 12% of female academic scientists who were professors at Columbia in 1943 were still in academic science by 1956, compared with 20% of men. So let me just show you something about the aggregate effects on participation, which I think is really important. So what does this do actually to science overall? This is the stock of scientists in 1956. And what you see here, there is a missing mass of scientists who would have been of childbearing age during the baby boom. women, there's a mass of women, there's a generation of women who were in their 20s at the beginning of the baby boom in 1945 who are missing. So participation by women declined by 16% in 1945. You can also look at this in terms of entry. So because we have employment data, we can figure out when people entered science. And what we see here is that 1945 saw a very large decline in entry by women. And that decline was driven almost exclusively by, or was driven primarily by women in childbearing age. Right? This is the last generation of mothers of the baby boom. Let me just conclude really quickly. So yes, reduce the productivity of mothers, but not fathers. A lot of this is that mothers have a different time pattern of productivity than other scientists. Mothers become more productive after age 35, and they become more productive 15 years after marriage. Basically, they become more productive when the kids are less work. That has important implications for tenure. Mothers are 21% less likely to get tenure compared with fathers, 19% less likely than other women. So what we see here is that these tenure penalties are actually driven almost entirely by women who have children. There is no evidence that mothers were less productive than other women. But female scientists, any female scientists, mothers and others, married late and had fewer children. Mothers and other women were also less likely to survive in science. And we see a dramatic decline in entry by women in their 20s in 1945. So what that suggests is, yes, there was a disparate impact, and it had an enormous cost for American science in terms of a last generation of female scientists among the mothers of the baby boom. Thank you very much, and we would really appreciate your comments.